Now that we've worked on graphing radicals and simplifying expressions with radicals, the last piece we need to work on is just solving equations that have radicals in them. So today's notes are going to be solving radical equations. So make sure you put today's date in the top right hand or left hand corner of your notes, wherever you have space. I'm just going to give you the steps to solve. And then give you some examples. So here's the steps to follow when solving. First, your goal is to isolate the radical on one side of the equation. So remember, isolate means you just get it by itself. So you want to undo the things that are going on around, outside of the radical, to get it by itself. Once you've isolated the radical, then you want to raise each side of the equation to the power of the index. And all that means is that if you have a square root in your problem, you're going to raise to the second power. If you have a cube root, you're going to raise that to the third power. Then your next step is to solve the remaining equation. So we're going to isolate the radical, raise each side of the equation to the power of the index, solve whatever's left over, and then the last step is you do have to check your answers. And what you're looking for is called extraneous solutions. Because we're dealing with radicals, sometimes the solutions you get might not actually work within the radical because you can't square root a negative number. So these are your steps that we're going to follow. We're going to do a couple problems together, solving radical equations. So let's look at our first example. Let's say you had the square root of 9x minus 2 equal to 5. So we're going to go through our steps. The first step was to isolate the radical. So the radical is isolated. There's nothing going on outside of it or after it. Everything is within the radical. Next, we're going to raise each side of the equation to the power of the index. Since this is the square root, we're going to raise both sides to the second power. Because what happens when you square a square root is that these undo each other. So the square root and the square cancel each other out, and you're just left over with what's underneath. That's why you need to get it by itself. And then 5 squared, we can just type it. We can do in our head, 5 times 5 is 25. Now you solve like normal. So I'm going to add 2 to both sides. 9x remaining equals 27. Divide by 9. X equals 3. We have to check our work to make sure that this answer is appropriate in this problem. So we're going to take the x equals 3 and plug it in. So I have the square root of 9x minus 2 equals 5. Plugging in 3 for 9, for x, excuse me. 9 times 3 is 27. 27 minus 2 is 25. So this answer does check out because the square root of 25 is 5. So you want to definitely make sure that you go back and check your work. Start off with your original equation, plug in the value of x that you found, do the math, and then make sure that these answers check out. And they do, because the square root of 25 does give you 5. All right, let's try another example. This time we'll just do the square root of x plus 5 equals 12. So remember, your goal is to get the radical all by itself. And you only can do that with things that are on the outside or in front of it. So since this is not underneath the radical, we can subtract 5 from both sides. If it was underneath the radical, we wouldn't be able to do any steps with this problem in terms of undoing numbers within the radical. So I have the square root of x equals 7. And now I undo by squaring both sides. The square and the square root cancel each other out. So x equals 49. And you can check that answer on the side. We start off with our original equation, the square root of x plus 5 equals 12. Plug in the value we got for x. Square root of 49 is 7. 7 plus 5 does indeed give you 12, so we're good. Let's look at another example. Here we have negative 3 square root of x minus 9 all underneath the square root equals to negative 24. So remember, your first step is to isolate the radical. So that includes everything underneath it. So we're not going to do anything with the minus 9 because it's underneath the square root. But this time I have a negative 3 in front. If the number's in front, remember it's like you're multiplying by negative 3. So to undo multiplying by negative 3, we would have to divide by negative 3, and we have to do that on both sides. So negative 3 divided by negative 3, that cancels out or reduces to 1. You have x minus 9 with the square root equal to 24 divided by 3. Negative 24 divided by 3 is 8. Now the radical is isolated, we can do our square and raise both sides to the second power. So this will cancel. And I have x minus 9 equal to 64. Keep solving by undoing. So I get x equals 73. And we can check to make sure that that answer works. We start off with our original problem. X minus 9 equals negative 24. We're going to plug in 73 for x. and then evaluate that from there. So 73 minus 9, that's going to give us 64. So negative 3 times the square root of 64. Square root of 64 is 8. So negative 24 does indeed equal negative 24. And that's solving radical equations. We'll do one more example, and then you should be ready to go for your practice problems in class. All right, last problem. We have the square root of 12x plus 4 plus 9 on the outside equals 19. So the first step is we want to get the radical all by itself. So I got to get rid of this plus 9. Since this plus 9 is on the outside, I can undo it. So I have the square root of 12x plus 4 equals 10. We're going to square both sides now. So the square cancels out with the square root. So I have 12x plus 4 equals 100, because 10 times 10 is 100. Subtract 4 on both sides. 12x equals 96. And then the last step is to divide by 12. So x equals 8. We can check that. Start off with our original problem. Plug in the value we got for x. So I have the square root of 12 times 8 plus 4 plus 9 equals 19. 12 times 8 is 96. Ninety-six plus 4 is 100. Square root of 100 is 10. And 10 plus 9 is 19. So this solution works out. So when you're solving equations that have radicals, you want to isolate the radical. And that means you undo the operations that are going on outside of the radical. Once the radical is all alone and by itself, then you can square or do whatever power you need to on each side of the equation. And then it's just solving like normal. So you should be ready to go for those practice problems now.